Okay, moving on to double angle formulas. So our double angle formulas come from the sum formulas, right? So we know sine, cosine, cosine, sine. So they expanded. If you expand 2u to be u plus u, then it's sine, cosine, cosine, sine, and the symbol is the same in the middle. But because those end up being exactly the same, right? Sine u, cosine u is the same thing as cosine u, sine u. You end up getting 2 sine u cosine u. So sine of 2u, or theta, is the same thing as 2 sine u cosine u. If you expand the cosine one, cosine, cosine, sine, sine, with the opposite symbol, right? But since they're both u's, you end up getting cosine squared u minus sine squared u. But remember, cosine squared u is an identity. So if you replace that with its 1 minus sine squared identity, another option for cosine 2u is 1 minus 2 sine squared u. Or if you had replaced the sine squared u with its identity, a third option for cosine 2u is 2 cosine squared u minus 1. So as we go through problems, we'll make smart decisions about which one we want to choose. If you're doing a proof and everything's in terms of sine, then you'd probably want to use the one that has only sines in it, etc. And then our tangent 2u, tan, 1 tan, ends up being 2 tan u over 1 minus tan squared u, or whenever possible, we want to just do the answer to sine over the answer to cosine. If you've already done sine 2u as a problem and cosine 2u as a problem, just take those two answers and divide them to get your tan 2u solution. So let's see how these are put into play. So we are finding sine 2u, cosine 2u, and tangent 2u. So we're finding all three things given this information. So we want to start, like always, by drawing the triangle in the correct quadrant. So I like to use the second piece of information first. It's between negative pi over 2, which is down here, negative pi over 2, right, going that direction, and positive pi over 2. So it's going to be not over here, right? It's going to be in one of those two quadrants. And then sine is positive. So out of the two quadrants left, sine positive has to be in quadrant 1, because sine is the y value. So this is for u, so I'm going to put a u in the corner. Well, I know sine has to be 7 over 25, so opposite over hypotenuse has to come out to be 7 over 25. Pause the video and do a quick Pythagorean theorem. You should end up getting 24 for the missing side, and it's to the right, so it's definitely positive. So now I have the picture that's going to go with our problem. So everything's going to come from this triangle that represents u. Now I'm going to do one at a time. Let's just start with sine 2u since it was the first one there. Sine of 2u is equal to 2 sine u cosine u. So it's going to be 2 sine of that picture, right? The u's represent the picture. Sine of that picture is 7 over 25. Cosine of that picture is 24 over 25. You can put the 2 over 1 if that helps you. Multiply straight across. If the numbers are this big, you might need a calculator. You get 336 over 625. That would be the answer to sine 2u. Now let's do cosine 2u. Maybe this is a good time to think about which of the three equations we want to use, right? Look at the given information. Given in the problem was sine u. So for those of you who are common at making mistakes on your Pythagorean theorem, use the equation that only uses the given information. So the cosine 2u equation that only uses sine is 1 minus 2 sine squared u. So 1 minus 2 sine of that is 7 over 25. It's over there in orange, and then you square that. So that's 1 minus 2, square the top, square the bottom. 2 over 1, multiply straight across. Common denominator. And the answer ends up being 527 over 625. That's the answer to cosine 2u. Now that I'm doing tangent 2u, Since I've already done sine and cosine, let's just take those answers and put them on top of each other, right? Tangent to u is sine to u over cosine to u. Well, since they're both over the 625, just going to tell you how it is. The 625s cross out. You could flip and multiply, right? And you just get 336 over 527. That's the answer to tangent to u. Notice how the denominators for sine to u and cosine to u were the same. If that doesn't happen, you did something wrong. Okay, let's try another one. So same directions. The directions aren't really on this page, right? But the same directions. We're going to find all three things. See if you can set up the triangle correctly. Pause your video. I'm going to pause mine, and the next time you see it, the picture will be complete. See if you can draw your whole picture completely. Okay, how's your figuring out which quadrant things go in and your Pythagorean theorem doing? It couldn't be at the bottom because it has to be between 0 and pi. And then cosine is negative, that means it's left. So left 7 is negative 7. Hypotenuse is always positive. 81 minus 49 gave me square root of 32 for the missing leg, sorry. And it's up, so I know it's positive. Okay, we're going to find all three again. Might as well just start with sine 2u. There's only one formula for sine 2u. Using my picture, sine of the picture is root 32 over 9. And cosine of the picture was also given. So put it over 1, multiply straight across. You get negative 14, because you can multiply whole number to whole number, but then root 32 stays the same. Over, and then 9 times 9 is 81. This is the answer to sine 2u. See if you can do cosine 2u. Look at what we're given, right? We know cosine for sure. So since there's so many choices, I suggest you use the one that has only cosines in it for your cosine 2u. That's 2 cosine squared u minus 1. So that's 2 negative 7 over 9 squared minus 1. Square the top and the bottom. Multiply straight across. Make a common denominator. You get 17 over 81 for cosine 2u. Since I had to find all of those, when I go to do tangent, it's easier if I just take my sine answer and divide by my cosine answer. Sine answer over cosine answer. The 81s cross out, and you get negative 14 root 32 over 17. This is the answer to tangent 2u. Okay, now that we know the double angle formula, we can expect to see them showing up in proofs and even solving equations. So in this problem, the first thing you should notice is that the x's don't match, right? This is just a single x and this is a double x. So we need to replace that. It happens to be sine. This is a solving equation. Notice the directions are solved, right? I'm not proving anything, just as a heads up. So the cosine x, 2 cosine x plus sine 2x. Sine 2x only has one replacement from our double angles. 2 sine x cosine x equals 0. Now it's back to earlier in the chapter, right? I got rid of the double angle for you. This is just a regular solve. So can you factor it and do zero product property and then plot the points on the unit circle and then see if they wrap together? You should pause it and try it on your own. GCF, zero product property, solve, plot, cosine is the x value, cosine of 0 is up here and down here, sine is the y value, sine of negative 1 happens to still be down there, so it's the same 2 points. They do wrap nicely because they are pi away in both directions. So x equals pi over 2 plus or minus pi n is the solution to this equation. But along the way, we used our double angle. Okay, now we're going to do a proof. So see the difference in the directions, right? Now we're verifying. We're going to leave the right-hand side alone, and we're going to get rid of the double angle. first, cosecant to theta is not a double angle formula, right? That's 1 over, the reciprocal of cosecant is sine. Keep the right side with you the whole time. Now I'm going to replace sine 2 theta using my identity now. Sine 2 theta only has one option, 2 sine theta cosine theta. Now if I separate this, so always keep an eye on the other side, right? I have 2 cosine theta at the bottom, so I want to keep the 2 cosine theta together. So we'll do 1 over sine theta times 1 over 2 cosine theta. Well, 1 over sine just is cosecant, and now it's over 2 cosine theta, so we proved it. Okay, so double angles could show up in proofs or equations or their own separate little problems, right? Finally, we have half angle formulas. So here's our half angles. Notice that the sine of theta over 2 and cosine of theta over 2 are almost the same, except sine has a minus at the top and cosine has a plus at the top. So we're going to keep an eye on that. And then also the symbol in the very, very front, it depends on where theta over 2 lands. And that's easier to show you in an example, but whether it becomes plus or minus will depend on where theta over 2 lands. And once again, tangent is the answer to sine over the answer to cosine. That's the one we're going to use most often. So calculate the exact values of all 3. And then they give us some information for regular theta. Okay, so notice that we're giving regular theta. So use all this information. I feel like we've done this a bunch of times together at this point. See if you can set the triangle up correctly. Okay, so adjacent over hypotenuse had to be 5 over 13. It was in quadrant 4. And then Pythagorean theorem gives me negative 12 for the missing side. Okay, now when we start this, we need to know where theta over 2 lands. So based on my picture, right, I've got it all narrowed down to quadrant 4. For sure this picture is in quadrant 4. That means, that's theta, that theta is between 3 pi over 2 and 2 pi, right? Quadrant 4 is between 3 pi over 2 and 2 pi. Well, if I really want theta over 2, right, all of these problems are theta over 2, then I need to take this equation, inequality, and I need to take this inequality and I need to divide it all by 2. So when you already have a fraction, that makes it 3 pi over 4. It's going to give me theta over 2, which is what I wanted. And 2 pi divided by 2 is just pi. So actual theta over 2 is between, let's draw a little set of axes for theta over 2. It's between 3 pi over 4, which is here, right, from your unit circle, and pi. So it's going to land here. But more importantly, it's going to land in quadrant 2, right? We cut it into an even smaller, like an eighth, but we know it's going to be in quadrant 2. So the decisions I make about plus and minus signs depends on quadrant 2. So here we go. Sine of theta over 2. Equation for sine of theta over 2. I'm going to do the plus minus in a minute. 1 minus cosine theta over 2. Okay, we decided we're in quadrant 2. In quadrant 2 is sine, which is the y value, plus or minus. Well, sine in quadrant 2, because everything depends on this one down here, is going to be positive because it's up, right? I'm going to draw a plus sign, but you don't need to draw a plus sign in the future. Then I'm going to do the math. So square root of 1 minus cosine of that picture is 5 over 13, all over 2. Then we want to do the fraction busting thing that we've been doing over and over again this year. Common denominator is 13, so I'm going to multiply everybody by 13. So square root 1 minus, nope. Also, I don't like that green. Square root of 13, because 13 times 1, minus the 13's cross out, so minus 5, over 13 times 2 is 26. 13 minus 5, 8 over 26. 8 over 26 reduces, 4 over 13. And then the square root of something over something is the same thing as square root of each one. Well, I can take the square root of 4, that's just 2, and then I would leave it over root 13. You do not have to rationalize these unless the multiple choice is rationalized for you. So that's our answer to sine of theta over 2. Figure out if your cosine of theta over 2 should be positive or negative. So cosine of theta over 2. Formula, I'm going to leave this plus minus blank for a second. 1 plus cosine of theta over 2. Okay, remember we're in quadrant 2, in orange down there. Theta over 2 is in quadrant 2. In quadrant 2 is cosine positive or negative. Well, in quadrant 2, that's left, cosine is negative. And then I'm just going to plug in what I know. 1 plus 5 over 13 over 2. Do the whole multiply by 13 thing again. Negative. 13 plus 5 over 26. 18 over 26, 6. 9 over 13, and I can actually square root the 9, 3 over root 13. Turns out to be the answer to cosine theta over 2. Finally, tangent. I think I have enough room at the bottom to do tangent because tangent is just the answer to sine over the answer to cosine, and if you've been paying attention, if you have a common denominator, it turns out to be real easy. Tangent of theta over 2 is going to equal answer to sine over answer to cosine. When the denominators match, you just get negative 2 over 3. Okay, so 2 new formulas that could show up in small problems on their own like this, or in proofs, or in solving equations. But that's the end of the chapter. So I hope you guys are doing good, and we'll practice more in class.